Hi, welcome to this Shout Education video. Here we'll look at what's in superglue and how it works. To be clear, before we go into the details, this video will only cover general use superglues that are available over the counter. We won't be looking at specialist variants that are resistant to heat or corrosive chemicals and solvents or medical grade glues. Pretty much all general use superglues contain only one active chemical. It's called ethyl cyanoacrylate. It's this chemical that reacts with surfaces to bind them together. So superglues are one-component glues. However, manufacturers also add chemical stabilizers to extend shelf life and control how quickly the glue sets. Since there's only really one chemical to look at, let's take a close look. The full name of the chemical in superglue is ethyl 2-cyanoacrylate, but the details of what the 2 means are less important. It's often abbreviated to ECA and referred to in general as a cyanoacrylate, but there are many other types of cyanoacrylate. Funnily enough, superglue is actually always second-hand, since the reaction used to make it makes the set version of the glue, which needs to be unset before it's sold. A molecule of ECA consists of 6 carbon atoms, 7 hydrogen atoms, 2 oxygen atoms, and 1 nitrogen atom. Pure ECA boils at almost 200 degrees Celsius, but in practice it will set or degrade before it gets that hot, making it a tough thing to measure. It is an irritant, and it can be used in medical glues, but there are other cyanoacrylates that work better. This molecule may look a little complicated, so let's break it down. Atoms of hydrogen, carbon, nitrogen and oxygen have different numbers of protons, and they bond in different ways. To make it a little easier, let's build up the molecule bit by bit. Each part of the name matches a part of the molecule. Ethyl, cyanoacrylate. The ethyl bit is made of 5 hydrogen atoms and 2 carbon atoms. They form this bit up here. The cyano bit is made of 1 carbon atom and 1 nitrogen atom. They form this group here with a carbon-nitrogen triple bond. And the acrylate bit is made of 2 hydrogen atoms, 3 carbon atoms and 2 oxygen atoms. Together, these atoms make up the active part of ethyl cyanoacrylate. But all these atoms and bonds are getting a little bit busy, so let's simplify them. Now we can move on to making the glue set. The carbon-carbon double bond is weaker than 2 single bonds, so it can react, releasing energy. Beware, at its most effective, superglue can release enough heat to warm twice its volume of water by over 60 degrees Celsius. ECA reacts with lots of different things, but the most common during home use is ordinary water. Moisture in the air can make it set in the bottle, and moisture on surfaces will accelerate the setting of the glue. The details are complicated, but the key thing is the water kicks off a much larger reaction. What follows is a chain reaction similar to an explosion that may involve tens or even hundreds of ECA molecules growing into a massive winding chain. But it's not just water that can kick this off. Reactive parts of surfaces like wood or skin can trigger the reaction as well. But how is this relevant to the real world? Here's a blob of superglue between 2 parts we want to stick together. When compressed, the superglue forms a thin layer. Ideally, the layer should be around 1/10 of a millimetre thick. If we take a closer look, we can see reactions producing chains from the bottom and the top. It's these chains that overlap and intertwine, helping to bind the layers together. In real superglue, the chains will be much longer and more irregular than this. Now, let's see what happens with a thicker layer. A thick layer or a blob of superglue may take a long time to set. A very thick layer may not ever set completely in a practical amount of time. Let's take a closer look to find out why. Chains can't grow forever. They'll eventually react with something else, with each other, or the growing ends will get trapped. With a thick layer, chains will grow from where the glue meets the surface and the moist air. The set layer forms a protective skin that slows the setting of the liquid in the middle. The upshot of all this is that there are a few things we can do to make superglues stick better and faster. If there's dirt or grease on the gluing surface, the glue will stick to that and not the surface. Cleaning the gluing surfaces first will allow the glue to stick and make for a stronger bond. Next, we can press the parts together firmly. This will make the layer of glue quite thin, allowing it to set quickly and completely. A good flow of moist air also helps, providing water to the outer surface that speeds up the reaction. You can also use baking soda, otherwise known as sodium bicarbonate, to set superglue. And lastly, we can heat the joint up. A little heat will speed up the reaction, but too much will degrade the glue. Above about 100 degrees Celsius, superglue that's set will begin to break down, turning back into ECA. So what useful things can you take away from this? Firstly, that superglue contains ECA, ethyl 2-cyanoacrylate, which reacts with surfaces and water. Secondly, thick layers of glue set slowly or not at all. And you'll find better gluing results when you have thin layers of glue, under pressure, with moist air and a little heat. If you enjoyed this video, please click the thumbs up icon or the subscribe button. Click the bell icon to get notifications.